All right, the last lesson was about the properties of exponents regarding products. So now we're going to do the property of exponents with quotients or division. So first thing I'd like you to do is some warm-up exercises. So pause the video and do those exercises, and then replay the video. Okay, there are the answers to the warm-up exercises. If either of those do not make sense to you, then please bring those questions to class. Here's our first key concept, all right? The quotients of powers property. Just like yesterday or the last lesson, we did the product of powers property. And when we were multiplying powers that had the same base, we would add the exponents. Well, division is the opposite of multiplication. So guess what? Instead of adding exponents, we're going to subtract them. However, I want to point out that we always take the numerator's exponent and subtract the denominator's exponent from it. So our bases here are a, that stays the same, and we take our numerator's exponent minus the denominator's exponent. A cannot equal 0 because we can't have 0 in the denominator. So here's another example without all variables. Here's our x to the 7th divided by x squared. Please ignore these, they are not negative. X to the 7th divided by x squared. My base is x, it remains the same. My numerator's exponent minus my denominator's exponent, which equals 5. 7 minus 2 is 5. So there's the first key concept. So let's do some examples. Maybe, there we go. All right, in this case, my base is 8. So the 8 is going to stay the same. My numerator's exponent is 10 minus my denominator's exponent of 4, leaving me with 8 to the 6th power. In this case, my base is -3. There's those parentheses, just like yesterday. The parentheses around -3, that's my base. My numerator's exponent is 9. My denominator's exponent is 3. So I end up with -3 to the 6th power, because 9 minus 3 is 6. Next one. This one's a little bit different. We have some multiplication going on in the numerator, and I want to point out that a division symbol, or the fraction line, is just like a grouping symbol. So we can consider doing this first, doing what's up here, before we actually do the division. This is kind of like parentheses or a grouping symbol. So we're going to do that multiplication first. Our base is 5, it stays the same, and we're going to add our exponents. So our base stays 5, and 4 plus 8 is 12. Down below, we just bring our 5 to the 7th power over. Now we're going to do the division, where our base is 5, and our numerator's exponent is 12, denominator's is 7, so we do 12 minus 7. So we have 5 to the 5th power. All right, I'm going to give you some guided practice, and what I'd like for you to do is see the problem, pause the video, attempt the problem, check your answer for each one. This is like our last example. So you're going to do the multiplication first, then do the subtraction. Okay. If you have any questions about those, let's do this one together. Or at least let's look at it like this. We have y to the 8th power. Let's look at it like it's over 1. And we can just multiply straight across. And 1 times y to the 8th, I'm going to do it over here, is y to the 8th. And then y to the 5th times 1 is y to the 5th. And now we have a normal problem that looks like we have what we have up here. So we're going to subtract 5 from 8, and we end up with y to the 3rd. Okay? All right, next key concept is power of a quotient property. So to find the power of a quotient, find the power of the numerator and the power of the denominator, and then divide or simplify, whichever. So it's very similar to the distribution into the parentheses with products. However, we have a numerator and a denominator. So the difference is this exponent out here goes with the numerator and the denominator because the entire fraction is raised to the power of m. The entire fraction. So we have a divided by b, the entire thing raised to the power of m, leaving us in simplified form with a to the m divided by b to the m. Our bases are different, so we can't simplify beyond that. B can't be 0 because it's in the denominator. So here's an example with an actual number for an exponent. So we have a divided by b. all raised to the power of 2. So the 2 goes with the a squared divided by b squared. So let's look at some examples of this. Maybe. Okay, so we have x divided by y, all raised to the third power. So it's kind of, again, like distributing the 3 into the numerator and the denominator, leaving us with x to the third, y to the third. And since the bases are not the same, we can't simplify this. Okay. All right, so in this case, we have a negative out front. And so we can put the negative with the 7 or the x, but I'm going to put it with the 7 because when I square this negative 7, it's going to become a positive number. So I'm going to go ahead and put the negative with the 7 and then distribute that square into the numerator right here and the denominator. And now I'm going to evaluate this negative 7 squared, which negative 7 times negative 7 is positive 49, all over x squared. Can't simplify that any further. Okay, at this point I can't simplify any further. All right, now we're going to actually use several of the properties of exponents. So we have a couple of things going on here. We have some division because we have this fraction bar, but in this division we have some multiplication in the numerator and some multiplication in the denominator. And we have this exponent outside saying this entire quantity is raised to the third power. So I'm going to use my power of a quotient property by taking this 3, and I'm going to put it with my numerator's quantity of 4x squared and my denominator's quantity of 5y. So I'm kind of putting it into everything. I'm putting the 3 with both parts, I should say. And then my next step is going to be taking that 3 and using my product powers, my powers of product property. And I'm going to take the 3 and I'm going to put it with the 4. And then I'm going to take the 3 and also put it with the x squared. It has to go to everything in the numerator. And the same thing with the denominator. The 3 has to go with the 5 and with the y. So just keeping that in mind. And I can't get my pen to work. Okay, so we can see if we can get this going again. Okay, see if I can get my pen to work. There we go. So I guess what we're going to do here is we're going to then just simplify. So my 4 cubed, sorry, that was my power of a product. I already said that. So now my 4 cubed becomes 64. My x squared to the third becomes x to the sixth. My 5 cubed in my denominator becomes 125. I'm just simplifying. And my y cubed just comes on down as y cubed. So now at this point, I look at my 2 numbers out front. They neither one have exponents other than a 1. So at this point, they're not bases. They are coefficients. So I'm going to look at these 2 like coefficients and see if they can simplify. Look at them as a normal fraction, 64 over 125. And I'm going to ask myself, can I simplify either of those two numbers? And I don't think there's anything that goes into 64 that also goes into 125 to allow me to simplify those. And my x is to the sixth, my y is to the third, my bases here aren't the same, so I don't believe there's any other simplification I can do. I don't have the same bases here, and this fraction is as simple as it goes. So I think I'm done. Okay. Next problem. Got a lot going on here. We've got some division, we've got some powers, we've got some fractions to the power or power of a quotient property. We've got some division here with some multiplication in the middle. Let's take it just step by step. So let's do power of a quotient. So we're going to go ahead and take this 5 and we're going to put it with everything inside the brackets. So a squared to the 5th and then my b to the 5th. So we just put it with everything. Okay. The 1 divided by 2a squared just gets carried along. So now we're going to simplify. We have a squared to the 5th, which becomes a to the 10th. My b to the 5th just it comes along. And again, the 1 divided by 2a squared comes along as well. And that's my power of a power. And then right here, all I'm doing is multiplying or simplifying. A to the 10th times 1 is just a to the 10th. b to the 5th times 2a squared. Well, my 2 comes out front because you guys, coefficients always need to come first. Numbers, real numbers, or integers, whatever, real numbers need to come first. So the 2 is listed first, and then my a squared, and then my b to the 5th. That's just alphabetical preference, I suppose. Okay, now that's just simplifying. Now I have to look at what I have the same. Well, in my numerator and my denominator, the only thing I have the same is I have these a's. I have 10 a's up here, and I have 2 a's down here. Okay, so I'm going to take my exponents. I'm going to subtract them. So in other words, I'm going to divide out 2 of these a's on the top and the bottom that are going to divide out to become 1, because a divided by a is 1. So that leaves me with 8 a's on the top because 2 of them cancel out. So 8 a's on the top, no more a's on the bottom. All I have left on the bottom is a 2b to the 5th. If you have questions on this problem, please bring them to class. All right, some more guided practice for you. Okay. Again, just pause the video after you see the problem, solve it, and then check. If you have questions about any of them, bring it to class. All right, let's talk a little bit about this problem here. The luminosity in watts of a star is the total amount of energy emitted from the star per unit of time. Now, just going to point out that first of all, this first sentence doesn't even have any bearing on the problem. Okay? The order of magnitude of the luminosity, in other words, how bright the star is 10 to the 26 watts. Okay, that's for the sun. So I'm sorry, the star. I said for the sun. The luminosity of the sun is 10 to the 26. The star Canopus is one of the brightest stars in the sky. The order of magnitude of the luminosity of Canopus is 10 to the 30. So they've given us the brightness of Canopus, and they've given us the brightness of the sun. And the next thing they say is, how many times more? Okay, when you read that phrase, how many times more luminous is Canopus than the sun? Okay, when they tell you something like that, when they ask you something like that, how many times more? Whatever is listed first is your numerator, and whatever is listed second is your denominator. So since Canopus is first, I'm going to use the value for Canopus, and I'm going to put 10 to the 30. It's basically asking how many times greater. And then the luminosity of the sun, since that's my second, so Canopus is first, the sun is second. I'm going to put 10 to the 26th right here. And I'm basically then I'm going to, divide this out. And 10 to the 30th divided by 10 to the 26th, well, my base is 10. And 30 minus 26 is 4, leaving me with either 10 to the 4th or 10,000 times more luminous. That means Canopus is pretty bright. Okay. All right, that is the end of the video. If you have any questions, please bring them to class, and I will see you tomorrow.